And welcome back. And it's the higher plus 5th of Feb. And let's go with the first question. Okay, what do we have today? So we've got to make W the subject. And as with yesterday, if you watch yesterday's video, the W appears twice. So I'm going to follow exactly the same thing I did yesterday. So you can see there's a little bit of similar methods each time. So I'm going to multiply both sides through by the denominator, which is W minus 5. And that's going to give me GW minus 5G is equal to W. Then I'm going to move all the W's left and everything that's not W right. So that's going to give me GW minus W is equal to 5G. And then I'm going to factorise out the W. So that's going to be WG minus 1. To be clear, I'm concentrating on the W. The W is the thing I want to factorise out and have on my own. And that equals to 5G. And then I can divide by the W, which indeed is the W on its own. And that's going to be 5G over G minus 1. And that is the first question done. Next question. Okay, I know what this is asking. So this is a clever way of asking you to do a little technique you probably learned probably second or third year, depending on when they taught it in your school. So I'm going to say, I'm going to ignore the 1, although actually, no, I'll tell you what, I'm going to do it all in one go. So I'm going to say that x is equal to 1.235 recurring. Then I'm going to multiply by 100 because I know I need to move it 2 decimal places because there's 2 dots up here. So if I multiply everything by 100, that's going to be 123.5, but then crucially 3535. So you will notice what I've done, although you can't see it very clearly, but I've got the 3 5s next to each other as the 3rd and 4th decimal place, and those are my recurring. So therefore, if I take the 2 equations away, 100x minus 1x is 99x. And 123.5 minus 1.2 is going to give me 122.3. Therefore, that means that I can say that x is equal to 122.3 over 99. But it says find the reciprocal. So therefore, the reciprocal is going to be 99 over 122.3. But there's a problem. I can't have decimals in my answer. So the neatest thing I can do is multiply everything by 10. So top and bottom by 10. And that gives me my final answer, which is going to be 990 over 1223. Now, if there's a calculator exam, what I then do, I'm pretty sure it doesn't, but I would type this into my calculator, divide by 1223, see if it simplifies. It doesn't, so that's my final answer. Next question. Given it gives me a function, find f minus 1 of x. Now, because x only appears once, there's a fairly simple way of doing this, which is I do a flow diagram. So what do I do to my x? Well, the first thing I do is multiply by 8, then I take away 1, and then I divide by 5. Let's write that slightly neat to divide by 5, which means my inverse function is going backwards the other way. So I'm going to take my x and I'm going to do it the other way. So I'm going to multiply by 5, then I'm going to add 1, and then I'm going to divide by 8. Nice and simple, falls out neatly. Next question. The areas of the circle and the triangle are equal. Express y in terms of x. Okay, right. Circles are all about radius. So here my radius is 3x, which means my area is equal to pi times 3x squared, otherwise known as 9 pi x squared. So the area of the triangle, I'm going to use a half AB sine C. So the area of my triangle is a half times 4x times y times sine of 30, which I'm going to write here, but I know sine of 30 is a half. So in other words, that's a half times 4 times a half, which goes away, and that just leaves me with x, y. This one falls out quite nicely, doesn't it? Now, the question says, again, always go back to the question, just be really careful. The areas of the circle and the triangle are equal. So therefore, xy is equal to 9 pi x squared. X doesn't equal 0, so I can divide by x, which therefore means that y is equal to 9 pi x. Express y in terms of x. I've done that. Question done. Next question. In a crate containing only red and green apples, the ratio of red to green apples is 2 to 1, so it's a probability question. An apple is picked at random and removed from the crate. A second apple is then picked. Okay. Second apple is then picked, so this is their conditional probability. So I'm guessing it's going to say something like, what's the probability of 2 reds or 2 greens? Let's have a look. The probability of picking 2 greens is y. Find the error interval for y. Okay. Yeah, clever, difficult question. I like this. If you haven't seen this before, you may not know what to do here. This is all based on the idea that, let's build it up step by step. So it tells you the ratio of red to green apples or green to red apples is 2 to 1. Now, how many green apples do I have? And the answer, of course, is I don't know. It's some multiple of 2. How many red apples do I have? And again, the answer is I don't know, but it's some multiple of 1, or in other words, x. Point is, twice as many green apples as red apples. The smallest amount of red apples I can have is 1 and 2 green apples. So if we assume it's 2 green apples, let's write it here. So if we assume 2 green apples and 1 red, then the probability of picking 2 green apples is going to be 2 over 3, 2 apples and 3 to choose from, times 1 over 2, because as the second choice, there's only 1 green left and 2 apples, which is going to give me 1 over 3. So far, so good. Now, there's a slight cheat for the next bit. So there is a proper limit way of doing it. Yeah, let's do it the other way. In general, I can say the probability of picking my first green apple, if I've got 2x apples, is going to be 2x over 3x. And my probability of picking my second one is going to be 2x minus 1 over 3x minus 1. So in other words, this is equal to, if I multiply this out, well, first of all, I can cancel these x's, can't I? So if I multiply this out, that's going to give me 4x minus 2 over 9x minus 3. Now, remember what I was doing up here. So up here, I was assuming the smallest number. So what I'm now going to do is assume the biggest number. So let's say x is massive, 10 billion, trillion. Well, then I've got 4 times a massive number minus a tiny, tiny number. That is basically, well, I'm going to write it this way. So I'm going to say let x get very large, so x approaches infinity. Then this is going to approach effectively 4x, because the minus 2 doesn't matter when x is large, divided by 9x. X's cancel, and that's just 4 over 9. That's a clever question. I like this question. Really well put together. So therefore, my error interval is any number between a third, which I can get, and 4/9, which I can't get to because I never get to infinity apples. Wow, we ended on a difficult question there, didn't we? If you got that one, well done. It might be one of those you've seen before with your teacher, or it might be one of those you sort of worked out by yourself. But either way, really, really good question to end on. Usual thing, like, subscribe, and I'll see you for tomorrow's questions. Thanks all.